All right, so we're back here again. We'll do our last little set of problems to just kind of get us started off. Okay, so remember that this was all about finding sample size. So all these formulas and all these problems are about finding an appropriate sample size to do our work. So for this first one, we'll start with 8.47. And 8.47, which is on page 373 of the fourth edition, is asking the researchers planning the study in South Africa will estimate the population proportion. So we know that we are finding a proportion. And with this proportion, they're trying to find people having at least a high school education. So we have no information about its value, so we're really not sure and how large a sample size is needed to estimate it within, so that we want a margin of error is at 0 or 0.07, and the confidence interval, we want 95% confidence. So you'll recall earlier from reading and in the text, right, if we really don't have any idea about what the proportion is going to be, we should use 50%. So the formula that we're going to use is we're finding n, the sample size, is equal to the estimated proportion times its complement and times the confidence level squared divided by the desired margin of error squared. So in this particular formula, for this particular problem anyway, the way that we're going to solve this is that we're saying the sample size is going to be equal to, so again, because we don't know any information of what that value might be, it's unknown, we use 0.5 times 1 minus 0.5. And because we're looking at 95%, that z-score is going to be 1.96 times 1.96 squared divided by the margin of error desired, that is squared, so within 0.07 squared. And if we solve this all out, if we broke this down again, it would be 0.5 times 0.5 times 1.96 squared divided by 0.07 squared. And this would ultimately break down to 196 people are needed to estimate the population of with n equals 0.07 with 95% confidence. So not too bad, right? Pretty easy to solve that one. So let's move to a different one. And which one do you want to do? How about, we'll do 8.5 because it has a lot of little problems that we can work in. So 8.5 is asking how many businesses failed. The study is planning to estimate the proportion. So again, we're looking at the proportion formula. Started in the year 2006 that had failed within 5 years of their startup. How large a sample size is needed to guarantee estimating this proportion correct to within, and it gives us a bunch of different ones. So A is asking, what's going to be, let's see if we had the proportion right there. So this is the margin of error that we want. And we have a probability of 1.96. So this is like the same formula that we've used before. We're still using 0.5. So just for a refresher, right, this formula is going to be n equals p minus 1 minus p, the complement, times z squared divided by m squared. And so for A, the way that we're going to approach solving this is, again, we don't know what that estimated proportion is, so we use 0.5. So this is equal to 0.5 minus 1 minus 0.5, 95% probability, so we know this is 1.96 squared divided by 0.1 squared. So 0.1 squared. And we would get, for number A, the answer is going to be 97. So let's go to B. So for B, it's asking the exact same thing, except we have M is going to equal 0.05, and we still want 95% probability. So that's also here. Whoops. So again, it's the exact same formula. So the way that we would set this up, use a different color here, is that this is going to be N equals 0.5 times 1 minus 0.5. And we're still using 1.96 squared. And the difference is going to be in this one, so that top part is the same as the other one. The only difference is going to be is that this is going to be 0.05 squared, so it's a smaller margin of error. And if we solve this all out, which I already have, so we're just going to have to walk through the math real quick, we should get 385 people. So, part C. Part C asks us, so we want 0.05 is equal to the N, the desired margin of error, but we want a 99% probability. Again, exact same formula that we've seen here, so I'm not going to write this out again, although we are going to make some changes into how we would solve this. So this would be N is equal to 0.5. Again, we don't know the proportion, the actual proportion, so we use 0.5 as a safety. But because we have a different value here, right, we want 99%, we use the 99% z-score, which is 2.575. Whoops, can't do writing. Let me erase that. 2.575 squared divided by 0.05 squared. And this would give us an N of 664. And if we looked at part D asks us to compare sample sizes for parts A and B, B and C, and summarize the effects of decreasing the margin of error and increasing the confidence level. So this one is pretty easy. So basically, if we look at a margin of error going down, we need bigger sample. So more precision requires a larger sample. And the same is true that if the confidence level goes up, so if we want to have less uncertainty, so if we want less uncertainty, we still need a larger sample. So that's the way it would work, you know, pretty straightforward, easy to understand. Sorry, let me take a big gulp right there. Okay, so we'll do, let's see, how many more do we want? We'll do one more, 8.57. So this is problem 8.57 on page 373. So this one is asking us about alleviating PMS symptoms, right? So it proposes that a new drug treatment for alleviating symptoms of PMS, it was successful, equals 7 out of 10. So equals 0.7 is a success rate. So we want a 95% confidence interval. And so what does it say, right? So first so basically what we want to do, we need to get like 14 to have like a balance for successes and failures. And so what we would end up doing was 9, wait, never mind. You know what? Forget this problem. We're not doing it. This one is like kind of like, it's kind of jank, and because it's jank, we're not going to do that. But we'll do 8.52 instead. 8.52, part 7.3. So it's like we're trying to find a mean acreage. So this part is key. We're not looking for a proportion. We're looking for a mean, an average amount. We want a 95. So find the mean acreage. We want a 95% confidence interval. And we want to be within 25 acres of the actual amount. And a study 10 years ago had a sample standard deviation. So we'll do standard deviation is equal to 200 acres for farm size. So for this particular problem, we're using a different formula, right? So for this particular one, because we're looking at a mean, the formula is going to be n is equal to sigma squared times z squared divided by the margin of error squared. For this particular problem, so the standard deviation is 200 squared times, and since we're looking at 95% confidence interval, times 1.96 squared. And because our margin of error is within 25, we would do 25 squared. And this is going to equal 246 squared. Or 246 is the sample size that we need to estimate the mean acreage. And so basically, then we have a different problem that comes up, right? And so if we look back at this, part B is asking us, sample is selected of size found in part A, so in this case, 246. So this is going to be equal Rn. But the sample has a standard deviation of 300 instead of 200. And so we still have a 95% confidence interval, but it's asking us what is the margin of error? So it's a different question, right? So we don't really know, basically, we don't have any formula for that because it's not something that we normally do, but we can still solve this algebraically. If I can get my pen color to not change, apparently, but whatever. So in this, we would have, right, we know that 246, if we just evaluated it, we're trying to find something else, we'll say is 300 squared. So we still have the sample size, we get that information. We have the confidence interval, which is 1.96 squared. And we're trying to find m squared, right here. And so basically what we would do is say m squared is equal to 300 squared times 1.96 squared. And this is 246 right here. And so, so all we did is just like flip it, right? Just basic algebraic manipulation. And we would find that if we did 300 squared times 1.96 squared divided by 246, and then we took the square root of that, that m squared is equal to 37.5. So right here. All right, folks, so that's it.